start. This is bound to happen, but welcome everybody. We'll make a start because we do have a lot to get in the hour, and I know that colleagues will be kind of arriving, but I'm keen that we get on with this session. Welcome everybody. This session is entitled Delivering High Quality Sustainable Campuses, which is quite a generic title, you might think. What we're actually going to focus on are the interventions and solutions aimed at very low carbon and in particular passive house solutions. You'll hear more about that from our speakers in a moment. I was conscious earlier in the opening session of the theme for today's conference. It's about net zero, and we all sort of talk about that these days, kind of taking that for granted, that we know what it is and therefore what we have to do about it. I think what we're trying to do is move on from the idea that we can get there just through a greenwash. This is really, today's conference very much about what can we actually do, how can we learn from other examples. And from our speakers in this session, you'll hear a bit more about some real examples of things that they have done, and hopefully some takeaways that will give you some reference points for going forward. So I'm Trevor Wills. I'm Director of Estates and Facilities at the University of Plymouth, and I'm Chair of the University Design Forum. And in our speakers this morning, we've got Mike Riley and Natasha Basile from BDP, hotly followed by Hugo Marak from Field and Clare Bradley Studios. And the aim is that we will keep to time, so I'll make sure that we do finish at 12:45 for lunch. And we're using up roughly 20 minutes for each of the presentations, and then we'll go to the bit that I think has the most kind of interest in terms of dialogue, is Q&A, where we can properly discuss some of the thoughts that arise. So please keep a note of any questions that occur to you during what's presented, and then we'll use those in the dialogue session at the end. Okay, thanks very much. Now over to Mike.
Thank you very much. So, as Trevor says, we're going to try and keep to time. So I will rush through some of these slides fairly quickly, but hopefully we'll have a bit of time for the Q&A at the end. So our talk today from BDP's point of view is about talking about the 8 steps to sustainable campuses. We work a lot in sort of higher education and education sectors, and therefore we can actually gather quite a lot of experience from the various institutions about how we do things. As already said, my name's Mike. I'm a technical director from the Manchester office, and this is my sustainability colleague who's stepping in for Lucy, who sends her apologies. Unfortunately, she couldn't be here today. So, without going into too much detail, BDP is a really large design practice. We've got multidisciplinary professions across urbanists, architects, engineers, etc. And we operate all over the world, and that gives us a bit of an advantage in the sense that we can harvest and get a lot of best practice from very large schemes, and we can transfer that, trickle that down all the way through all our projects. But enough about us and what we do. It's more about how that can actually affect all the things that you're all doing on a day-to-day basis. So when we're approaching a design scheme, what we tend to do is we look at sustainability in sort of 8 principles. And I'm not going to use today to go through every single case study and show you how each case study complies with each one of these principles, but I think it's really important to look at this as a holistic thing, and then we'll pick out various topics as we're talking. So, you know, for a sustainable campus, you have to think about the energy, you have to think about carbon, you have to think very hard about the materials you use and how you can actually minimise the impact on the environment by reducing the amount of material that's being used in the building, and that's really good because it reduces cost as well as the sort of carbon and the energy, etc. It's about then having a regenerative thing about biodiversity, minimising our water usage, etc., while still considering things about how the environment is going to change over a period of time. You know, we're all seeing the sort of, you know, Old Trafford was the 4th largest waterfall in the UK for a small part on Sunday night, wasn't it? So, you know, those are the sort of things that are really important for any large estate owners. And not only all of that sort of good stuff about the building, but it's about the people in the building. You know, keeping everybody healthy, making sure that we're tracking the performances and quality of the environments that they're in is really key. So as the first one of our 3 sort of case studies, we're going to talk to you very briefly about the University of Warwick. To give you a sense of, this is a science and engineering precinct that we're developing for them, so very high energy usage just by the nature of the activity that happens in it. It's right at the heart of the campus of Warwick, so it's really near the library. It's part of the 1960s original elements of the campus. And it's an opportunity for them to really revisit some of the sort of ageing estate and the ageing scientific buildings that they've actually got as part of their faculty. So in terms of the process that we go through as BDP, one of the critical things to talk about is to understand from the client what is it they are actually their key criteria, what are our success factors, what are the core principles of our design. So for this particular client we said, you know, it's got to be low carbon, it's got to be low operational energy in use, and that's really important because this saves the client money. As they're going through and they're operating the building for, you know, the next 25, 30, 60 years, having that energy efficiency is really critical to them, and they really feel the benefit of that. Business as usual is absolutely a given. You know, we've got students coming in, this is a large building, it's going to actually take up 3 years worth of construction. Having the opportunities to get business as usual is really important to them. So getting things like the modern methods of construction, off-site fabrication, bringing it to site, just-in-time deliveries is really important from a continuity of campus operation. And then it's about flexibility. Their existing building stocks have lasted for 60 years. They've had all sorts of different science processes, research coming through the doors, and actually they've had to adapt the buildings and the structures over that period of time to suit the needs of modern science. So it's actually looking at the design from day one. How do we incorporate that flexibility into the scheme? Because actually if you do all that sort of stuff, you get a building that lasts for a long time. I mean, I just think it's important when we start talking about carbon that we talk about it as a sort of process which is a well understood, hopefully, set of principles. You've got your embodied, you know, the physical carbon that's associated in the building itself. Then you've got the operational carbon that's running it. You've then got potential offsetting for the sorts of emissions that you've got to get this whole life net zero carbon building. So in terms of our approach on this particular project, we were tackling the embodied carbon by challenging that, do we need this material in the building? You know, that's a core principle. Do we need ceilings? Do we need raised access floors? How do we design that out? How do we design the infrastructure of the building so that it's actually a lot more intelligent and focused? How do we get the operational carbon down? Well, that's, you know, fabric first approach. It's about making the buildings as efficient and effective as possible. Therefore, you know, going for a passive house certified or passive house certifiable building is really important because that enables the actual intent to be verified and proven. And then it's minimizing carbon offsetting. We want to do as little as that as possible because actually we've done an intelligent, engineered building right from the word go. So to set ourselves a bit of a sort of understanding, we've looked at all sorts of industry standard targets. We've looked at the HOK labs targets, we've looked at the LETI standards, the lab challenge from the RIBA, and we set ourselves a target which challenged those high energy usage buildings and dropped it by about 10% off those sort of 700 kilograms per metre squared down to about 650. So we looked at the context. Then we looked at the buildings that the university had themselves. We started to say, well, you've had a very strong sustainability policy for a long period of time. You've delivered 7 buildings, I can't count, over the last sort of 5 or 6 years. They've analysed the carbon on it, and then we've looked at what our project target was compared to what they'd actually managed to achieve. And therefore, we were benchmarking as much as we were actually looking at the industry standards. How do you approach that then? We looked at where can we have the most impact. You know, if I save 10% of the FF&E carbon, you know, I save myself very small fries comparatively. Focusing our attention on those big hitting items, where the MEP is, the facade, it's the structure of the building, the superstructure of the building. That's where we're focusing the attention. If you can get 10, 20% out of all of those, you can effectively pay for some of the smaller hitting elements. And I could go through hundreds of different ones that we've established here, but I think I just picked on the structure because it's kind of easy to communicate really quickly. What we did is originally a science building, say 5, 10 years ago, we would have instantly gone back to large span, reinforced concrete slabs, 10.8 metre grid, clear soffits, you know, that is just the sort of status quo from about 10 years ago. So we looked at the performance of these slabs because you do have vibration criteria, you have research responsibilities to actually make sure that the building performs. And we looked at how you set labs out, how do you set labs out for different types of science, and then we actually got a sort of matrix of opportunity where you've got timber being introduced into the building where you've got the lower performance, and you've got the concrete just where you need it. It's just where that scientific research requires it to be. But it's not from day one as well, it's really important to say. It's about a future flexibility. It's like how much extra capacity have researchers got to grow their vibration-sensitive research from just where it is today to where it will be in 10 years. And then you get this sort of hybrid effect where we go, right, okay, where we've got people spaces, we're going to go for timber, where we've got performance spaces, we go from concrete. We get this combined elements together, and that's how we sort of really target improvements in what we're doing. This is, we're working with Archetype on this project, and we're working with them very cleverly on a load of projects. They put this graph together to then look at the operational carbon of laboratory buildings generally, and demonstrating to the client that actually if you go for a passive house certification, you not only get that highly engineered, highly designed building, but you also get this, this performance verified. It's certified, and you can therefore, not guarantee, but you've got much more of a proven building there that is possible to do. So again, on this basis, all this research, we set a project target. It was challenging. It was below the HOK labs target. It was below the RIBA target, etc. But that's carbon. That's statistics. That's sort of things that are sort of intangible. So what do we do about that to actually make this into a proper design for the actual university? So it's the heart of the campus, and it's about actually taking all of those back-of-house spaces that are really sort of surface car parks, surface yards. They're not very user-friendly. It's about then creating this sort of biodiverse, regenerative area in the centre of campus that really gives back to the students and staff, and then surrounding it with the science and engineering precinct. It's about the idea that people are important in buildings. Showcasing is really important. It's about making spaces then that will enable those to be on show and actually enable people to engage with the development. And understanding what parts of the faculties, where do they go, how do they fit in the building, making sure that the research and the workplace are set appropriately. How can we reuse existing building stocks so we put workplace in existing refurbished buildings where the performance criteria is less stringent, and where we put the highly scientific spaces in the brand new facility that's custom designed for what they actually need. And then again, people are about, as everything BDP does is about the users, it's about the people. It's about creating spaces that people actually want to use, they want to be part of. So creating identity, areas for people to collaborate, is central to the whole scheme of the project. And then as an overall piece then, as we're going through it, we're trying to communicate to everybody what are the key elements of our design. It's about having a low energy infrastructure that supplies heating and cooling to the building. Ground source heat pumps, air source heat pumps, they're all very efficient ways of heating and cooling buildings. It's about having this fabric first approach, which talks about the passive house. It talks about a good performance, airtight building that's thermally efficient and effective. It's highly engineered, and it's using those MMC, green roof to help biodiversity. We're capturing all the elements of the design and communicating them in a way that actually is easy for the client to understand. And as you can tell from the sort of diagrams, we're quite early on in the process, and this sort of describes to you the sort of thoughts that we go through. I'm now going to hand over briefly so that we can talk about LSE, and it will go a little bit further into the process and draw it to a conclusion towards the end.
Thank you, Mike. Hello, everyone. My name is Nastasia. I'm currently working on a building which is literally next door, and it's at 35 Lincoln's Inn Fields, and it's for the LSE. We are developing this building, basically. The LSE wanted to develop the most sustainable building they've had so far. And so they hired BDP to be their sustainability consultant on the client side from the day one of the project. And BDP has developed a very, very ambitious sustainability brief from day one, and also a design competition brief, which includes sustainability targets. So what happened is LSE put in a design competition for various architects. You had 6 different architects who applied to become the lead architects on the project. They had different proposals for the building. The one architect who got selected was the only one who proposed retaining the building. They were proposing retaining 60% of the structure of the building, and they're David Chipperfield's architects and their team. So in terms of sustainability brief, we have developed something. I don't expect you to read what's in the table. But key things that you can take away from there is operational energy. So we have set from day one very ambitious operational energy targets, which are aligned with the REBA climate challenge targets. We have also set up really ambitious embodied carbon targets that's related to the material usage of the building. Biodiversity net gain, the building is achieving 100% biodiversity net gain, so that means it's a massive improvement compared to what was previously in terms of greenery for the building. And circular economy-wise, we have pushed the team to really maximize the reuse of the building, retaining the building, which I will talk about in the next slides. So in terms of retaining the building, you can see a cross-section of the building there. The brown bits are what's being retained in that 2D drawing, and the white bits is the extension. In the axiometric view, that 3D view, the light brown volume is what's being retained, darker brown is being modified volume, and the red bits are what are being added to the building. So we're not just interested in just retaining some bits of the building and do whatever for the rest of the building. We are interested in reusing some of the elements that we are going to be deconstructing from the building. We're going to be reusing it for the proposed building. So for example, internal partitions, a lot of them are made out of bricks. We want to reuse those bricks for finishes, for example, on the ground floor, where you have that render, and just really appreciate the value of the existing building. Another thing that we are considering is when the enabling works contractor are demolishing partitions, etc., or walls, they might not be able to salvage bricks as they were initially. So there's going to be broken bricks and things like that, and we are looking into making tiles, which are shown here, which are remade out of those broken bricks. So it's terrazzo tiles. So all of this reuse, etc., really helps in terms of meeting the embodied carbon targets of the building, in terms of minimizing the reuse of new materials. We're using 6% of the structure, etc. And so the building is on track at the moment in terms of meeting the targets. We're also looking at minimizing finishes, so you don't have finishes if you don't need them. That's as a starting point. Reusing raised access floor panels where we can, using eco ducts, which are like very low embodied carbon ducts. In terms of operational energy, we are achieving, I don't know if that means anything to you guys, about 42% carbon reduction against Part L 2021, which we think is an achievement for something which is, mostly reused with a bit of extension. So in terms of the strategy for the operational energy, so it's a mixed mode ventilation building. You've got mechanical ventilation for the winter for all of the spaces, but in the summer, the offices are naturally ventilated. You have the option to use them VHRs when you want. For the lower floors and the upper floors, you've got big lecture spaces, so they have to be mechanically ventilated. In terms of the facades and the thermal envelope, because part of the building is existing, the challenge was to try to reduce improve the performance, reduce the U values of those walls to the maximum, but at the same time being really careful about the moisture condensation for those walls. And so the facade engineers have worked really hard on doing WUFI analysis, which is moisture analysis on the walls, etc., while at the same time optimizing the performance. Of course, we're using SOC pumps, high-efficiency SOC pumps for heating and cooling, and we're maximizing PV on the roof as well. We're using rainwater harvesting for the toilets, for irrigation. There is a blue roof on the top of the building and a green roof, so blue roof in order to store rainwater, basically. In terms of BREEAM and WELL, and so this building is targeting BREEAM Outstanding, WELL Platinum, and Passive House. WELL is like the certification for the well-being of the occupants of the building. Passive House, I'm sure you heard of, and Hugo will talk about it more. So we've done a lot of workshops with the design team from the beginning of the project in order to make sure that everyone all the stakeholders know what are their responsibilities in order to achieve those certifications, because it's never just sitting in the responsibility of the sustainability consultant. It has to be a teamwork where everybody is involved. We will be doing post-occupancy evaluation for the building, so to make sure that the people who are using the building are happy and comfortable using it. I'm not sure how much time I've got. Okay. So in terms of lessons learned, get in early. Sustainability consultants need to be involved from the inception of the project. It's so important to have a strong sustainability brief from inception, cost the project appropriately from early on, and get the buy-in from the client and the cost consultants. Embodied carbon savings and cost savings come hand in hand very often, and engage with the design team and the clients from early on for Brian as well.
I've left myself with 2 minutes. One more to bring you together. There's one more to bring you together, thank you. And I've got 2 minutes, right? I will go through this really fast. So, that's universities. They've got lots of money comparatively to schools, right? This also works on very challenging other projects where you've got to solve problems. Wardle, too small, needed more students. Got a very old building that they wanted to regenerate, redundant facilities, and it didn't really work for them. So we took some of the influences from BDP projects like St John Bosco, the Nightingale Hospitals, Box Park, very fast, very quick projects. We had to deliver it very quickly to the start of the new academic year. We created these learning sheds, which are sustainable kits of parts. There was very reduction of waste. It was all designed to the module of the material being used. The shape of everything that we put together made sure that we minimised the type of waste that was being thrown out of the building, and therefore it could also be an easy, simple technology for the students and the apprentices that worked on the project to actually understand. Again, that thing about well-being was an integral part of it, using sustainable materials. These are a couple of the examples that show how it looked as the design developed, and then how it was actually delivered. This idea of actually taking that sketch and actually being really rigorous about driving that vision through from inception to completion was fantastic. So, in conclusion to the BDP element of it, we've shown you three highly sustainable buildings. They're fundamentally all focused around the people that use them. So all of this sort of work that we do, all of the intelligent engineering that we create and put into our schemes is all about making life better for the people who end up using it. Thank you, everybody. Now that is the gentleman.
Thank you, Mike and Natasha. Brilliant. Okay, we're now going to hand over to Hugo. It looks like you're good to go.
Thank you. I think I need to actually come out of this. And
Sorry.
That's all right. But I've noticed there's a few people standing. There are a couple of seats here.
Good. Two here. There are some others.
Near the exit, I get that. So hopefully that works. Hi, it's great to be here. My name's Hugo Marek. I'm the architect and partner at Phil & Bradley Studios. These days I wish I was also a scientist. Our work includes academic, cultural and social settings at universities, but my presentation today is around places for living at universities, and via these three projects to sort of, I suppose, give a bit of a practical journey on our approach to sustainability. There's a climbing scale to the size of the projects. We'll start with a small social hub, and then a medium-sized student residence, and then quite a large student village. So, and what I should say actually is the common thread through all of these is passive house design, targeting low energy, and I'd like to think a holistic approach to sustainability. I'm just going to check that clock over there. It's great. So our first case study for Kellogg College in Oxford, they wanted a new hub and cafe building which would bring together their campus and their residences. And here's the site. It was a collection of Victorian villas and their gardens, and the site for the hub is the confluence of these gardens in the centre of the college. This was our first concept, a barn-like outbuilding, which took us into the competition. And then when we got this far, the college and the university wanted to use this project to test passive house on their estate. So passive house. Passive house, the core principles are to minimise heat loss and therefore energy in heating within a building by super envelope, super specified envelope, and mechanical ventilation with heat reclaim. Those are the principles. Now, what this does is it places the actual energy load from a passive house at about 40% of an equivalent BREEAM excellent building, which is very general, but there's a performance there. And as Michael was alluding to, that performance has a lot to do with the scrutiny and thoroughness of the detailing and workmanship of those buildings, so that the actual performance of a passive house design is very similar to the design. The performance gap is brought right down, and that's the reason for its success. So what that means is that, looking on the left bar there, current building regulations in yellow, operational energy, we're moving down into the middle with heat pumps as renewables, and that's seeing a sort of actually a 90% reduction on current building regulations, which is pretty phenomenal. Passive house principles, some of you will know this, apologies to those who already know this, but at early stage, it's about form factor, the right amount of surface area on the building to the gross area in the building. It's about optimum glazing in terms of the proportion of glazing and the orientation of glazing, and it's about using modelling to understand the energy load. As we go into the developed design, it's about super insulation, super airtight, and super controlled in terms of the mechanical ventilation. It's very simple, very passive, although it has moving parts with ventilation. And then in the detail, we're talking about rigorous detailing, a complete understanding of buildability and sequencing, and a very, very thorough monitoring of the work on site. So we took all that. This was new. This was about 10, 12 years ago, relatively new to us. We took that, took it back to Kellogg, and what did we do? We turned the building round. We faced it to the south with the social spaces. We removed the pitch roof to reduce surface area of the facade, thickened up the fabric, and we introduced a south-facing canopy, if you like, so that we were just enjoying positive winter solar gains rather than overheating from summer gains. So maybe relatively simple, but a simple building to start on. We then took our concept and completely made that fit with Passive House, which was a simple pavilion at the confluence of these garden walls. The plan, seeing social spaces gravitate towards the south, obviously protected from summer gains, and then FM spaces, everything else pushed towards the north. And the sort of the degree of measuring the openings, the window openings, was pretty fraught because we weren't working with a sensible form factor. A lot of scrutiny, a lot of learning curve on site for the contractor as well, in terms of tolerances of insulation, sort of achieving weather or air tightness, sorry. And then that's the building in its finished form, with getting all the windows in the right place onto the gardens, and its exterior, which doesn't look like a typical passive house, as some people probably know them. So, lessons from this one. Did I start at 5 past or 10 past?
10 past.
Yeah, great, thought so, great.
You're doing okay.
Okay. Advisable to take to decide on passive house right at the beginning of a project. If you don't, the suboptimum form is going to really limit design choices down the line, and the learning curve on air tightness and insulation tolerances are challenging for both the team and the contractor. And so actually getting through that, doing mock-ups, doing extra training are all pretty essential. So our next passive house project was for King's College, Stephen Taylor Court. The college wanted a new community for around 80 people, all within a unified and distinct landscape. Again, we brought passive house to this, but we started it with it this time. We added low embodied carbon to the menu, and then a palette of air source, ground source, and I can come on to those, and BHR and biodiversity within the landscape. The big move here was the awareness of overheating, as well as trying to prevent loss of heat. And so starting to look at ground source heat pump as a way of delivering cool passively as well as heat is starting to be a very favourable idea. So this is the before and after site sketches, and there are 3 crescents forming an open court to the street. Crescents of sensible proportions, form factor, pitch roof, but actually using that pitch roof, and also sensible plan form as well. And one of the tricks, or one of the sequences, to get this environmental or the ventilation strategy into the plan right at the beginning. So relatively simple, albeit radiused plan because of the crescent. Looking more outwardly now at the landscape, the space between those 3 crescents is working very hard. Below the lawn, there's a milk crate attenuation reservoir for rainwater, which is fed by rain gardens that wrap around the outside of the buildings, which also give privacy, which are in turn fed by all the roof discharge. So all the water's going, and it's going back out into the site. The project's off-grid in terms of public sewer, and we added in a swale there to manage extreme weather events. Within the architecture itself as well, trying to understand Passive House, but make the sustainability in a way invisible, I suppose. We're working with cross-laminated timber structure, window linings, which I'll talk about, timber window linings, integrating MVHR into the facades, into the free area in that vent there that you can see, and also feature rainwater pipes into the rainwater gardens. So there's a sort of strategy and an architecture coming together to find the character. That was an aerial of the project with that central court. And then bringing Passive House again into the details, quite simple. You just got to know what you're doing. It's about very specific wall build-ups, quite space-hungry wall build-ups. It's about getting your air tightness modelled in 3D so you understand it. And the CLT is great because it's also your air tightness layer, so you're just into taping. It's about understanding sequencing and buildability so that you're not making late changes and introducing cold bridges, which are the enemy of Passive House. And then a lot of care in window design, actually, and not just in how they function, but how they can be replaced after 30 years. So here we use timber reveals to partly bridge the extra gap on the insulation within the walls, but also to allow a proper opening up of that aperture and a replacement of the window and an adequate replacement of all the air tightness seals around that window back to the CLT. At Stephen Taylor Court, the CLT structure has absorbed, has sequestered more carbon from the atmosphere as it grew than the carbon emitted by the timber, by the brick facing to the facades. And in fact, there's a 0 line there if you look towards that. The CLT on day 1 in terms of upfront emissions, what's happened to the day the building opens, the CLT matches the carbon load of all the other materials in the building, which makes it a very attractive proposition for structure if it's in the right place. Here it is. It goes. I'm not working for KLH or whoever. No sponsorship here. But it goes in quick. It goes in fast, which means you can start working on the interiors of the building at the same time as finishing off the facades. This was just the curved roof. That was harder than it looks. And then some finished photography of the building with the rain gardens and permeable paving within the landscape. The way the buildings open up, that's the reason for the crescents, opening up that court to the street view. And because we worked hard and fast to the Passive House principles at the beginning, the rules, we were able to break the rules down the line. And so, for example, projecting bays in timber or the projecting dormers. And also this is an essay for architects in the old-fashioned window and sill height rather than floor-to-ceiling glass and so on, how to make a facade accommodate those kind of relatively ordinary window openings and have character, and character of the interior again by timber, which is there for homeliness but also acoustic absorption. So, lessons learned from this project, getting the right form factor, allows you flexibility down the line. It isn't too constraining working with passive house, as long as you know where to break the rules. Heat gains require as much attention as heat losses, especially with the way our climate is changing, and so using ground source for coolth as well as warmth via an underfloor heating or cooling system is an option. And window operations, and this is one of probably the biggest challenges, is educating users in how to use or when to use the windows. In winter, you probably need to think like a Northern European. In the summer, start to think more like a Southern European. In other words, if it's warmer outside than in, you keep the windows closed, which is slightly counterintuitive to people in this country. So there's an education aspect to this project as well. And then our final case study is a much larger campus or a student village for Staffordshire University. 1,000 study bedrooms, 0 carbon, but actually not defined at the time what that meant, passive house. And this was taken up to REBA stage 3 to go on to inform the developer-led procurement process. So it's a theoretical project slightly. Our environmental strategies, building on the ones we've described before, hot water demand, big thing in student residential, so meeting that with air source heat pumps, which we were locating outside the buildings, so we're not increasing sort of the footprints of the buildings, very low heating demand, sort of trace direct electric radiators, and as much PV on the roof as we could get in, and also MVHR, and then as we found out, CLT. So for this project, our concept was living in a wood, because we all would like to do that. I think I would. And so a landscape strategy for the project that was underpinned by biodiversity. We were targeting net gains on this brownfield or greenfieldish site. Biodiversity and also embedded creative water management throughout the whole site. And all those things add up to settings for health and well-being for the students. So, that's probably where the money needs to go in projects like this, is where the money or the value certainly comes out of the projects, and everyone's a winner. Now, on this project, it became very much about metrics. A square metre of carbon for a whole life of a building, I think, a square metre of space is around a tonne of carbon. Every square metre counts, and we started to talk about there being just enough, working out what's just enough accommodation, and also how that accommodation and the space is used really carefully. That's a form of sustainability, how we consume space. Again, simple building forms, not over complex or making things more complex for work down the line, and starting to think about the architecture as the backdrop rather than the foreground. The backdrop, simple, elegant backdrops for green, for the garden settings. And like a primer on passive house, a primer on carbon, we established eventually that we were going to try and achieve net zero whole life carbon for this project, which is, I think, about as high, the LETI definition is about as high as you can aim. What that means, sorry, I'll go back to this. What that is the sum total of operational and embodied carbon within the whole life, so from cradle to grave for the building. The intention, the LETI definition is that is minimised or absolutely possible on site via design and construction, and inevitably there'll be a residual area, and that's met by offsets. And this is a minefield for designers and for clients to navigate. Quite simple, but actually how far do you go on site? How far do you go with design within limited budgets? And then in the green there, what's the, how, are we over relying on offsets? And what is the offset provenance or authenticity of the offsets? That's a difficult world. It's a bit of a rabbit hole, I find. This is slightly easier. Where's the carbon on 4 or 5 more minutes? What was that? 4. Great. This is easier to understand where the carbon is within the building, within the project. For current building regs, there on the left, about 2/3 of the carbon is within the operational energy for the building for its life of 60 years. But because we're doing so well with low energy and have been working on it for much longer, that's shifting the emphasis now. And so you'll see there on the right that the embodied carbon in the building and the carbon involved in the materials on replacement parts through that lifetime are now around 3/4 of the building. So the emphasis, it's like, well done everybody, the emphasis really needs to shift onto embodied carbon as well. And there you see actually half of that embodied carbon is in the superstructure. And so going back to this diagram, now talking about the pink bar, elements of the bar, we're somewhere in the middle, and we need to get to where we are on the right by 2030. And it's hard. So for this particular project, we tried to simplify things slightly, and we disaggregated us into landscape, operational, and embodied carbon. That was our approach, quite simple. The landscape consultants had to make it look after itself, using natural materials, minimising cut and fill, and minimising hard landscapes generally, which is a difficult thing on campuses. There's a tension there with accessibility. But also they could rely on the future offsets on site from tree planting, wet soil, wetlands. Wet soil absorbs about 30 times the carbon of dry soil, apparently. Oh, I'm being filmed. We might need to fact check that. Operational carbon, this makes it look quite bad, but actually you've seen where we are, 10% of building regs. Offset pale blue there with photovoltaics. And we're getting there. Over time, that's going to be met by a decarbonised grid because it's a gas-free project. Until then, there's an offset equation to be found to balance the operational energy books. And then in terms of the superstructure, in terms of the embodied carbon, a lot of emphasis on superstructure. And I'd like to share, we found that we did a full value appraisal of CLT, and surprisingly, as well as winning on carbon, it was also winning on cost, it was winning on program, and it was winning on buildability. And so that was going to be our preferred route, say, over light gauge metal frame. And so this is where we got to with upfront emissions, day one, construction's finished on the left. Now if you factor in the timber sequestration, there below the line, we're getting very close to balancing the books on day one. However, over the lifetime of the building, on the right, the replacement of the MEP services after 30 years has a significant effect. And also you'll note that the sequestration below the line in the lifetime emissions has disappeared. And that's because there's currently a general assumption that at the end of the building's life, that timber is going to be burnt or wind up underground, and in either event, it's going to emit carbon back into the atmosphere. So we're not allowed to count that. But my view on all of that is that it's if you can use timber in construction, it is preferable to emitting carbon right now, this year, next year, the next 5 years, if you can. Great. I also think it's good for us to promote the stewarded forests and that supply chain. And I also think we've got a lot of work to do to work out in 50, 60 years how to reuse, recycle the timber in our buildings so that that sequestration, that carbon sink, carries on well beyond the life of the actual building. And so, sorry, lessons learned, I'm out of time. Lessons learned, shift to embodied carbon, spatial metrics, because that's consumption, is just as important as our operational energy. And also, early on, wading into the terms of measurement with a client about how you're going to achieve net zero and what things are worth, because there is a big debate going on about that out there. And that's me. And collaboration is key.
Really good, thank you. Can the three of you take your seats out front, please? Take a breath, Hugo. That's really good. Lots of rich content in both of those presentations, I think you'll agree. I'm hoping there are lots of takeaways in there. What I will say is, in trying to chair the session, I feel a responsibility to do some jargon busting. So if you heard any acronyms or descriptions that didn't mean anything, please ask and we'll answer it. So really looking for questions. First hand up.
I'm just wondering for Hugo, I don't know if you mentioned it, but how do you find like the issue of insurance with fire?
Well, not insurmountable is the answer to that. Insurers, certain insurers will insure timber frame structures, but you're right, like Zurich will, for example. And also, certain insurers won't say no to insurance to a university. What we did on the village in particular is we engaged through the process and met with the insurers to describe what we were doing and risk management, etc. They were more worried about spread of fire than loss of individual assets. But you're right, it is a challenge. The mindset in this country towards timber, mass timber construction or mass timber structure is one of the biggest challenges.
And if I can add to that as well, as the Alliance for Sustainable Building Products have actually released a document that sort of has the sort of 26 steps of things that you can actually do to talk the insurer's language. So actually you go through these sort of this sort of process and you talk about risk and what is the risk of the building getting lost and how do you manage that through, you know, good compartmentation, sealing up the timber where you need to, stopping fires from spreading, sprinklers, you know, you add all these things into the mix. I tend to find with universities and schools particularly, they tend to have really good relationships with either their broker or the actual people who are insuring themselves, and they tend to have people who are responsible for the campus fire strategies. So good collaboration and chats early in the process and looking at the sort of industry-wide documentation can really help because you're putting it to them in a way that they can understand. You're talking their language, and that's part of the sort of benefits, I think, of actually of going through that rigorous process.
That's quite right, education. The Zurich initially said we'd just like the whole world to be built from concrete. That was their approach.
Okay.
Thank
you. Any other questions?
I think every case study mentioned passive house in some sort of form. Just interested to get your view. I think, Mike, you had on the bottom of your presentation about something like passive house principles doesn't guarantee thermal performance.
Oh, you've got really good eagle eyes there, haven't you?
it was in orange at the bottom.
Yeah.
So just the sort of merits of pursuing a certified passive house building other than a building that is just passive house principles, so very thermally efficient.
That was to protect his professional indemnity.
I think that's the critical thing, isn't it? That actually the thing that we talk about a lot is the engineering principles of passive house and the paper, the on-paper element of it to prove that a design can work. But the other part that people don't talk about very much is the on-site quality assurance parts of it, which I think you touched on quite well in your talks as well. And that actually sort of really brings together a sort of high quality construction that's well supervised by the contractor and well documented, and that sort of on-site supervision is the piece that actually drives the quality up. So it's good simple design principles, engineered and tested digitally through BIM processes, calculator tools, etc., and then actually following it through and making sure that it's buildable on site and it's checked on site, and that's the really important thing. So a lot of people, when we talk to them, and say, oh well, if we just put the tables out of the passive house standards, would we get the same performance? It's like, well, probably not, because we're still in the same site processes as we are today, and with that sort of attitude, you just get the same sorts of problems with the building at the end of it.
If I could add to that, in a way you don't have to do passive house. If you can build into your specifications the tolerances on insulation, the airtightness requirements, you're sort of there. Those are the things that are really important. The difference between a 5 mm and a 2 mm gap between your insulation band is huge. So in a way the principles are great and could be brought, we should bring them more into our specification writing.
Hugo used a phrase about knowing where to break the rules,
Yeah.
which I was curious about, but I think that comment there is a bit of a clue as to where you need to be slightly nimble about how the rules might apply.
Yeah, see if they're reading this.
Yeah, sorry, Natasha, are you going to add something?
Yeah, I just wanted to add that I think also passive house certification, actually going for certification as part of the brief of the project, will actually enforce it in the design team. among all of the stakeholders, because otherwise it can be brushed off quite easily and there's no consequence. So we try to
Rules
follow.
straight away,
Yeah, I think having actually a certification process and having to do those modeling and checking if we're on track or not, and that influences the decision making, because if the client wants it, that's it. You know, you'd have to drive the decisions early on.
Okay, other questions, please? Over the back.
Congratulations on the projects, they were really informative for us. I'm just wondering how much consideration, and maybe it's something that's built into the certification process with Passive House, but what happens when 5 years' time, is there anybody going back to check to see that they're actually performing to what was designed and what was intended? Just, I suppose, the performance gap question, as it were.
I think that's a really valid point, and actually I don't think the certification requires you to go back and do it, but because the clients have invested so much of their effort and attention to actually go for the certification or go for the Passive House in its inception, they want to make sure that they're getting what they paid for. So going back and actually doing the post-occupancy evaluations is really important. And we tend to find, I think, more that large estate owners do this very rigorously. They want to make sure that their buildings are performing, they're fine-tuning them correctly, and they're not actually, the users aren't doing something a bit odd, like, you know, it's hot outside and all the windows are open, letting all the hot air into the building. Do you know what I mean? Those sort of things and that sort of education all comes out of that post-occupancy evaluation. I think, anything to add?
I've got something to add, yeah.
Go on.
And talking about certification, it's not just, for example, you've got Passive House, but then if you're pursuing BREEAM and WELL, actually they require you to follow up on the performance of the building post-occupancy. Especially for WELL, you have, because it's about the well-being of the occupants, so you have to recertify every 3 years to make sure that the air quality is still good for the occupants, etc., and is functioning as designed.
I think it's fair to say there is a bit of a trend, isn't there, in sort of certification things to actually double check that you're still meeting it in a few years' time. Neighbours is well known for this, that you can get a 5.5 neighbours today, and in 5 years' time it might be a 3 because things have moved on. So actually that's a definite trend we're seeing in how people assess and think about buildings.
Yeah, I would add that we would recommend a sort of soft landing at least a couple of years after completion, which is more fees. But most buildings are prototypes and sort of adapting to what is learned at practical completion and adapting the systems as you move forward. So it's really worthwhile, soft landings.
I also think that a lot of colleagues in the room will be end users or represent the client groups, and often buildings don't get used in the way it was intended or designed for. And so, as much as anything, communicating those design and use principles to end-user colleagues who may not be from outside the tracks at all. You know, they're just there to teach in a space, and therefore, quite how you get that across is quite valuable. Otherwise, the whole thing gets corrupted, as Mike was saying. Other questions?
Yeah. So, in terms of Passive House, the DFE are obviously experimenting with having Passive House schools and building that into the standard spec. I think in Scotland there seems to be more Passive House schools than England. What do you think are the main stumbling blocks for Passive House and avoiding? You know, why is it not in the DFE standard spec, for example? Obviously, there's elements of the U values are better U values. The air tightness is good, but why do you think full Passive House schemes aren't more common?
Good question. It might be one for Crawford later as well, but we'll have a go at it.
There used to be a rule of thumb that it would add about 5 to 10% onto the construction value of the project, but I think I'm not entirely sure that's true. I think that it's because you're asking for a higher specification, which brings value and return. You are asking for a higher specification that also comes with a cost, and so it's going to probably limit the access in terms of the right supply chain. And so on. But I think it's also a mindset thing. It's very new. It's relatively new to this country. In Europe, it's been going on for 30, 40 years. In fact, in sustainable design, it's been going on for 60 years. It's just got a name now. So I think that as it gets traction as a concept, a principle, if not a certification, those prices will come down.
And I think we are seeing that general trend that prices are reducing. And I think there was, on the university projects we work on, there's a lot of attention around, well, what investments are we making as a client, and when is the payback time? You know, what is it that we're actually going to get, and when is it going to give us a proper return on our investment? I think conversations like that, we as architects, so sort of 10, 15 years ago, wouldn't necessarily have been so involved in those sorts of conversations, but we're finding that we're getting more involved in them, and therefore the whole life cycle costs and the whole life cycle energy of projects, we're becoming much more well versed in talking that type of language, because it's what clients want to hear and understand about the designs they're getting. I think that thing about quality on site is also something that worries some of the contractor teams. They look at it and they go, well, I've got to sign a contract that says I am going to do this. Am I confident that I can do that? And that is a worrying thing for them until they've done a few and they understand the processes.
It's totally supply chain. Contractors having access to light gauge metal frame, metal steel frame subbies working in, and then, or you're going to go and work with KLH imported from Europe and so on. It's very supply chain based.
Okay, other questions?
Hi, so this is for you, Hugo, the last presentation. So I noticed that you didn't mention any PV panels or any use of more renewable energy, and I was wondering if the use of that will offset the carbon emissions, the operational carbon.
Yeah, actually, on the village, all the roofs had were pretty much covered in PV, and that was picking up, I think, about 15% of the operational energy. With the student residences, with Stephen Taylor Court, there was some quite difficult conservation area issues to manage, but we have done a study and we have put the infrastructure in for PV. And I think that helps almost to bridge the gap on operational energy. So the infrastructure's there for that to happen, and we're talking about that at the college.
Thank you. Any other questions?
The Institute of Structural Engineers had quite a strong view on where sequestration sits in the RICS life cycle. And given that mass timber in this country is in its infancy, how do you reconcile your design decisions with the fact that most mass timber comes from Scandinavia or the Alps? Because obviously that transportation is going to have a huge impact.
That's built into those the calculations I was showing. That's built into the embodied carbon. Yes, transport is definitely an issue. In terms of reconciling that, the best type of timber that we can use in our buildings is fast-growing British softwoods that are in sort of a 20-year-old. There's no and so to start generating, we're working with some firms out in the southwest who are starting to work much more with their local timber supply, trying to promote that industry. It's got to be a good thing. I would rather a demand there to encourage people to invest in forests than cement, the next cement plant. Basically, that's just common sense. So, and it's a finite resource as well. And so, I was thinking about art of Japanese joinery or Japanese house building. 1,000 years ago, limited resources on the island, they were working out how to make sort of big beams with meter-long sticks, with just very crafted junctions. And we've got CNC cutting now and these devices. So I think it's actually, it's not just, it's timber. You could do a lump of timber and your carbon would be, off the chart, be fantastic. But it's actually still, you have to use it sparingly and cleverly, because it's a finite resource like anything else.
Okay, we have time for one more question. We're like an auctioneer. Over to you, sir.
We've probably all had experience of passive house being dropped on projects and sort of the principles of passive house being continued, but then that quickly perhaps fades and it isn't what it perhaps should be. What are your tips for encouraging clients to stay the course?
Put in the brief from the beginning, from the project brief. If you want a passive house certification, it has to come from stage one, even before you hire the design team. Like when you're costing the project from the beginning, it's in the brief, and then this is how I think it's the best way of implementing it in the project. Because also the design decisions that you're going to make at the beginning of the project they're less costly than if you wait and getting involved later down the line, and also you have less opportunities to change things the further you wait down the line. So you might think, oh, do I actually need a sustainability consultant at stage 1? You know, I'm going to save some money now. But actually, you will save so much more money if you do that, thinking about it from the beginning of the project.
Okay,
So, yeah.
Good takeaway, thank you. Michael or Hugo, any quick takeaways to add to that?
Well, I would say the likely reason for it to be let go is budget, is cost, and so we've just got to work harder in those early stages to stay on budget and stay on cost and work within the limitations of that. Otherwise, yeah, it'll go, or it might. And but that being said, the principles are still in the scheme, maybe not the specification. There's still some benefit in that. It's better to have started at least with that as an aim rather than not at all.
Okay, thank you, Mike.
I think it being an integral part of the project culture, if you talk about it in all of your meetings, the client's on board with it, that's like I was saying right at the beginning of Warwick, you know, we look at it, we talk about it, and when we make decisions, we say, well, how does this affect our carbon targets? How does this affect Passive House? And that decision framework becomes part of the culture of the team, and they then think about it every time. And then actually we tend to find that other professions start coming to you with suggestions, because actually you talk about it so often, they go, well, actually I've had this really good idea, let's investigate it. And actually it becomes much more of a collaboration, and therefore that is the best way from my point of view.
That's right, and don't let it be the bad guy. If you know, becoming the bad guy.
Yeah.
If you're not working within it, you're the bad guy. You've got to. It's too easy for it to become blamed for everything. So
my reflection on that last comment would be there's something about normalising this and getting everybody familiar with what it is, bearing in mind that we're dealing with colleagues or client groups that won't be working in this world. So in the same way as we used to talk years ago about the student experience, and that just caught on as a language, you know, Passive House or related aspects of that, as the presenters have said, need to become normalised so that we just get familiar with that, and dare I say it becomes a bit of a self-fulfilling prophecy, but just the idea that it's real. On that note, I'm going to finish. We're on time for lunch, so thanks everybody. Can we just thank our team?